Okay, let's get started. Okay, so today we are dealing with word problems. We're going to work certain ones of these, and then you're going to work the rest. We're going to kind of break it down and break these up so that we can make them a little bit easier to solve. All right, first things first, okay? The first thing that you do is define the variable, okay? That means that you're going to make the let statements. We're going to say let x equal something. Use the let statements to define your variable. We're going to say, what are we letting represent x? Your second step is, yes, you have to write the equation, set up the equation, and then solve it. So keywords, translate into an equation using your let statements, then solve, okay? It's kind of one way of thinking about it. It's the process to get to something equal to the something. It's one way to think about it. And then you define your answer. Okay, give exactly what the problem is asking for. You have to make sure that you're answering the question asked. Answer, question asked. That's important. You have to make sure that you're answering the question that is asked. Okay, we're going to jump to number 2, because if you can do number 2, then you can go back and do number 1. All right, so it says the larger of two numbers. So the larger of two numbers is equals probably 7 less than. Less than means subtraction. The word than means I'm flipping the order. 3 times, times means multiplication. So I've got a 3 here, a 7 here. That's probably going to move to the back. The smaller number. All right. I have 2 unknowns. Larger and the smaller number. The larger one is dependent on something to do with the smaller number. So therefore, my first let statement is going to be let x equal the smaller number. Now I can describe the larger number with this information, because it says the larger is 7 less than 3 times the smaller number. 3 times the smaller number, that's going to be 3x. 7 less than this, so I'm going to say let 3x minus 7 equal the larger number. Now that just told me what the variables are, like what I'm looking for, the smaller number and the larger number, how I can represent them. Now we go into the next part of this. The sum. Sum means addition. It's the answer to an addition problem, okay? The sum of the numbers is 61. So that means I'm going to have the small plus the large equals 61. And I'm going to take what's representing each one and plug it in. So I'm going to have x plus 3x minus 7 equals 61. And now I solve. Combine my like terms. And I have 4x minus 7 equals 61. And now I continue to solve. So I'm going to add 7. This zeroes out, and I now have 4x equals 68. Divide by 4, divide by 4. And this is when it's very nice to have the handy dandy calculator. And I get 68 divided by 4, which is 7. So I have that x equals 7. not 7, 17. 17. X equals 17. Okay, so we've done our solving. Now we've done our solving to find out what X equals, but that's not my question. My question is to find the numbers. That means I have to find both. The smaller number, I found X, that's 17, but I still have to find the larger number. So what I have to do here is plug in X to find larger number. So I'm going to be doing 3 times 17 minus 7. 3 times 17 equals 51 minus 7, which gives me 44. So therefore, the two numbers for this problem are 17 and 44. This is your answer for this problem. Okay, moving on to a little bit of a different example. Number 6. Remember, if you've got questions, you can stop and ask me. Okay, for number 6, it says Garrett has $1 less than, it's minus, and we flip the order, 1 less than, so that's going to be a 1, that's going to flip the order, 3 times as much money as Liz. 3 times, so that's multiplication, number 3, as Liz. Well, together they have 17. So together, that means I'm going to be adding. They have 179. How much money does Garrett have? So I only want to know how much Garrett has. Okay, well, I've got 2 variables. I've got Garrett and I've got Liz. I don't know either one of them. But Garrett's depends on Liz's situation. So first things first, I got to label my variables. So I'm going to let X equal Liz's money. And then I'm going to write my next expression for Garrett based on Liz. So I know it's 3 times as much money as Liz. So that's going to be, so let 3x and then $1 less than, so it's going to be minus 1. That's going to represent Garrett's moolah, Garrett's money. And now it says together. So that means I'm going to add. So I'm going to have Garrett plus Liz equals the 179. And now I'm going to plug in that information. I said Garrett first. So Garrett's is going to be 3x minus 1 plus Liz's, which is x, so it's plus x equals 179. And now we solve. So I combine my like terms and I get 4x minus 1 equals 179. So I add 1 to both sides. 4x equals 180. Divide by 4. X equals, divided by 4, I can't type, 45. Now, you could stop here and think, oh, I found out what X is, I'm done. But X is representing Liz. I don't want to know Liz's amount. This is $45 that Liz has. I need to know Garrett's amount. So that means I've got to plug this in here. So I have 3 times 45 minus 1. 3 times 45 is 135 minus 1. So that gives me that Garrett's money is $134. Okay, moving right along. Now we're going to talk about perimeter of a rectangle. The thing to remember when we're talking about the perimeter of a rectangle, it has a nice formula that we can always use. you can always remember that perimeter means to add all sides. When it's a rectangle, it's got this nice formula of P equals 2L plus 2W. So anytime that you're talking about a rectangle, you can use this formula right here because the rectangle has 2 lengths and 2 widths that are the same. Okay, so we're going to jump down and we're going to look at number 11. I'm trying to do the ones that might have a little bit more detail in them with you, and then the other ones are a little bit more basic. So therefore, I'm doing a little bit harder ones with you when we're going through these. Okay. It says the length of the rectangle is, so the length is equals 3 centimeters. I like to work these. Okay, length is, so that means L equals 3 centimeters less than, so that's subtraction, but it's that reverse order again. So it's going to be minus 3 twice the width. Okay, so that's 2W. But I can't have 2 variables. So that's what I would write like this right here, but okay. So we're going to say L equals, so this is my length. The width, we're going to say W equals, or we're going to let W, I need to make sure I'm writing this correctly and being consistent. Let W equal width. And then we'll say let 2W minus 3 equal the length. Sometimes it's kind of easier to work like this. All right, so now we're going to use our nice formula for perimeter. Remember, P equals 2L plus 2W. Well, what you need to remember is it tells us right here, if you read further into the word problem, the perimeter of the rectangle is 18. So it gives me that information. The question is, I want to find its dimensions. That means I want to find the length and the width. All right, now I plug and chug. I take this information and I plug it in. So I'm going to have 18 equals 2 times the length is being represented by 2W minus 3, close parentheses. The width is W, so plus 2W. And now I solve. Distribute and solve. So I'm going to have 18 equals 4W minus 6 plus 2W. Combine my like terms, and I have 18 equals 6W minus 6. Add 6, add 6. Oh, I'm looking at the wrong one. Add 6, add 6. So now I'm going to have, I'm going to move this over here. So I'm going to have 24 equals 6W. Divide by 6, divide by 6. And 4 equals W. It's talking about centimeters. So right now I know that my width is 4 centimeters. But I'm not finished because I need to also find the length. So that means to find the length, I'm going to be doing 2 times 4 minus 3, which is going to be 8 minus 3, which is 5. So I end up with the length is 5 centimeters. The width is 4 centimeters. This is that answer. And the rest of them are all very similar. You're plugging into that perimeter formula. Okay, next set of examples. We're dealing with consecutive numbers, okay? This is kind of a different way of thinking about things. When you're talking about consecutive, okay, that word consecutive means one after another. For instance, 3, 4, 5. Those are consecutive numbers, okay? That's an example of consecutive numbers. All right, so, oh, which we did right here. 3, we're gonna hit 3, 4, 5 are consecutive numbers, which that's numbers. Now, what if we don't know what they are? If we don't know what they are, then that would be X, and then what do I do to go from, change colors really quickly. My first one is X. The second one, what do I do to go from 1 to 4? Plus 1. So the next one is going to be X plus 1. Well, what do I do to go from 3 to 5? Plus 2. So my third one here is going to be X plus 2, and so on. And you increase as that. If it's even, consecutive even numbers, that's going to be numbers like 2, 4, 6. Who do we appreciate? Okay. Dot, dot, dot. So now we have to think about, okay, my first consecutive number is always going to be X. Now I've got to talk about how is it related to the next. What do I have to do to 2 to get to 4? Add 2. So my next term is X plus 2. What do I have to do to get from 2 to 6? We add 4. So the next even integer is X plus 4, and so on. Now, what's nice about the next scenario is even and odd can be thought of as the same, even though that's not the same number. Because my consecutive odd numbers would be 1, 3, 5, and so on. But let's look at the relationship between them. Again, the first number is always going to be X. Then I'm asking, okay, how is the second one connected? What do I have to do to the first to get to 3? What do I have to do to 1 to get to 3? Add 2. So my second one is going to be X plus 2. What do I have to do to 1 to get to 5? Add 4. So the third one is X plus 4. Whether it's even or odd, it is the exact same expression for finding the next terms. That's what's nice about those. Even though it's saying even and odd, you still work the same way. All right, let's work some examples here, guys. Looking at 14. It says the sum of, that means it's adding. I'm adding them together. 2 consecutive integers is, so that's equals 123. Find the numbers. Notice I'm circling what I'm looking for. All right, so my game plan here is I'm going to do well, let's label our variables first. So we're going to say let X represent the first consecutive number. Well, if that's the first one, my second one is going to be, we're going to let X plus 1 represent the second consecutive number. All right, so my game plan here, I'm doing the first plus the second is equal to the 123, is equal to the total. All right, now I plug in my numbers. So I'm going to have the first is x, the second is x plus 1 equals 123. Combine my like terms. And I now have 2x plus 1 equals 123. Subtract 1, and I have 2x equals 122. Divide by 2, divide by 2. X equals 61. Now, it says to find the numbers. That means I need both. Right now, I know that the first is 61. Well, obviously, I'm going to do 61 plus 1, and that's going to give me the second of 62. So my numbers are 61, comma, 62. Okay. Next example, 16. A lot of word problem examples. So this is going to take some practice and going back over. But remember, you can always go back to the video to watch. All right, here we go. Now, the only thing we're changing here, only difference is we're talking about even. So we're no longer using just consecutive. We're talking about consecutive even. Find two consecutive even numbers whose sum is 54. So we're still doing the first plus the second is equal to 54. The only thing that we're doing is changing that we're going to let x equal the first consecutive even number. We're going to let x plus 2 equal the second consecutive even number. This is the only difference, this right here. All right, so let's plug it in and go. So I'm now going to have x plus 2 equals 54. And then we solve, add my coefficients, and I now have 2x plus 2 equals 54. Subtract 2, 2x equals 52. Divide by 2, x equals 26. So I know the first one is 26, so I'm going to do 26 plus 2, which gives me the second one as being 28. So my numbers are 26, comma, 28. Okay. One more example. And I'm going to let you loose. Okay. Looking at number 19. The sum of three consecutive odd numbers is 57. What are the three numbers? There's two things that are different here. We're still talking about sum, so I'm still doing addition. 3, so instead of having 2, I'm going to have 3 consecutive numbers. They're odd. So, but I work those the same way I do even, so I'm still good. Is 57. We want to know what all 3 numbers are. So first thing I got to do is label my variables. So let x equal first consecutive odd number. We're going to let x plus 2 represent the second consecutive odd number. And then we let x plus 4 represent the third consecutive odd number. Okay, game plan. I'm adding the first. I'm doing the first plus the second plus the third equals 57. So now I plug in my info. So I have x plus 2 plus x plus 4 equals 57. Combine my like terms. So I have 3x plus 6 equals 57. And now we solve. So I'm going to subtract 6, 3x equals 51. Divide by 3, and x equals 17. So that's the first one. So the first number is 17. It's 3 consecutive odd numbers. So I should know that this should go 17, 19, 21. So my answer is 17, 19, 21. Your assignment is to finish this notes page and then check in with me after you have checked your answers. Have a great day.